Okay, in my previous video I said you could spare some time because it was quite an easy one. This is a question which needs a bit of working. It's an HL question, so SL, please move on if you're watching this one. We're going to look at simple harmonic motion. We're going to think about the speed of the object when it's halfway between its equilibrium position 0 and its extreme position. Takes a bit of working, not nice maths in here, but we can do it together. Try the question, and when you've either got an answer or you've decided you can't be bothered anymore, feel free to watch the video. All right, like I say, I think this involves quite a bit of working, quite a lot of stuff to pay attention to, but we can manage this. I think the confusing thing is this B. I remember when I was doing it the first time, I kind of lost track of some of my notation, and I'll try and make it clear for you guys. First thing I would do here is look at the calculation of speed of an object in our simple harmonic motion. So you've got this equation here, which is V equal to plus minus, I'm missing a plus minus there, omega times the square root of x naught squared minus x squared. Okay, now x naught is our amplitude and x is our position at any given time. So firstly, our x naught here is the amplitude. You notice here you've been given b. Now the amplitude is not b, it is b over 2. And I think that, like I say, I think that's where this question can be a bit annoying. If you miss something like this, you're going to get the wrong answer. We want to know when we're at halfway between equilibrium and extreme. And so actually we're going to be looking at the position not b over 2, but b over 4. And again, that's where I found this one a bit tricky. So our x is going to be x naught over 2, b over 4. Now, hopefully, we can do the maths, okay, and look at this horrible bit of work, okay. We're going to say v is equal to omega x naught squared, x naught over 2 all squared, okay. We're going to put that in here. We're going to get omega equal to 3 x naught squared over 4, okay, where x naught is b over 2, yuck, all right. We're remembering also that omega is 2 pi f. Okay, so we're going to remember to firstly take out our square root of 4 here on the bottom. That's going to cancel the 2. So I've done some of the cancelling just to make sure it fits into the screen for you here. Okay, if you just take some time, pause the video, look at where things are coming from. The main thing here is this factor square root 3. Okay, that's going to allow us to rule out some of these answers. And then the fact that by subbing in x naught equal to b over 2, we've got b squared over 4. That b squared over 4 is going to get square rooted to give you a b over 2, which is why the answer here is D. All right, now there's a lot of working out here. As I was explaining that, I kind of realized maybe there's a better way of me doing that. However, I think you can see there that the process is here. Now, I think the bit that I think students forget about is this equation here, this v. Often, we've got two equations for v. We have one which is as a function of time. This is v as a function of x. There's no dependence on time here. So if you're using the equation v equal omega x naught cos omega t, that's not going to give you anything here. You're going to have to use the dependence with x. All right, so like I say, have a look at the working there. I'm sure there's a neater way of doing it. If you want to try and send me that, that'd be great. However, hopefully you can follow my working there.